Expecting that you put it where the sun is, it would relax to the circle of Jupiter, concrete, truly unsteady, and going to detonate. These effects are among the best impacts of radio energy in the whole universe, making more energy than a billion suns. Have you figured out what will happen? Betelgeuse, a giant red supergiant star and one of the nearest stars to Earth, has actually gone through significant darkening that has stood out and mixed feelings all around the planet. This darkening has led to hypotheses among cosmologists and the general public about its natural repercussions. A few experts believe this astounding behavior could be a precursor to a massive impact, a staggering event that happens when a star depletes its nuclear fuel and collapses under its own weight, leading to a tremendous explosion. Such an event raises concerns among standard specialists as well as the general public because it poses questions about the potential impact on our planet. Betelgeuse is a prominent star in the Orion constellation, easily recognizable in the night sky due to its distinctive shape and brilliant stars. Also referred to as Alpha Orionis, it holds the title of one of the brightest and largest stars in this magnificent body. Recent data gathered by NASA's Hubble Space Telescope, along with observations from various observatories, have shown that Betelgeuse experienced a massive mass ejection in 2019. This event is astounding for a star of its kind and has ignited interest among stargazers worldwide. While coronal mass ejections are common in our own sun, the unusual event observed in Betelgeuse adds a fascinating layer to our understanding of stellar life cycles and the behavior of massive stars. The distance to Betelgeuse remains a subject of debate among space experts. Some estimates suggest it is farther away, while others indicate it could be as close as 724 light-years from Earth. Precisely determining the distances of red supergiant stars like Betelgeuse is a complex task due to their immense size and unique properties. Betelgeuse stands out as one of the brightest stars visible in our night sky, boasting a luminosity significantly greater than that of the sun. However, this massive wonder comes at a tremendous cost. Betelgeuse burns its nuclear fuel at an accelerated rate, hastening the inevitable end of its brilliant light. Eventually, the star will deplete its fuel supply, leading to a dramatic collapse under its own gravitational pull, possibly resulting in a massive explosion that could form a neutron star or even a black hole, according to current astrophysical theories. This raises a critical question. Does Betelgeuse pose a threat to Earth? If a supernova were to occur a few hundred light-years away from our planet, the consequences could be devastating. The impact of a supernova explosion can release an enormous amount of light, potentially rivaling that of an entire galaxy. Even if Betelgeuse is relatively far away, the effects of its cataclysmic explosion could be significant and far-reaching. Notably, since the last observed supernova in our own system in 1604, humanity has yet to witness such an event nearby. However, a visible supernova did occur in 1987 in the Large Magellanic Cloud, 169,000 light-years away. While that event had enormous effects, it posed no direct threat to Earth, serving as a reminder of the scale and potential impacts of such cosmic phenomena. The concept of a risk zone surrounding a typical supernova explosion is intriguing and could have serious implications for life on Earth if such an explosion were to occur nearby. However, it is essential to understand that, in the vast cosmic landscape, nearby supernovae are relatively small events compared to gamma-ray bursts, which are far more powerful and pose a different kind of threat. Gamma-ray bursts can have devastating effects, capable of destroying biospheres and irradiating planets with lethal radiation. For instance, certain types of gamma-ray bursts can deplete a planet's ozone layer, leaving it vulnerable to harsh space radiation long after the initial impact. This potential was highlighted in a recent study that illustrated new threats associated with massive stars that end their lives spectacularly. When massive stars explode, they can reach some of the brightest luminosities known in the universe. In fact, the brilliance of a single supernova can surpass the combined brightness of billions of stars. This raises a question. What would happen if Betelgeuse were to undergo such an explosion? If a supernova were to occur, Betelgeuse would become the second brightest object in our sky after the Sun, even visible during daylight hours. Despite the distance, Betelgeuse would shine brighter than a full moon, casting shadows even at night. The sheer intensity of the explosion would create a spectacle so astounding that it would leave a lasting impression on observers. While the visible light from a supernova is stunning, it is only a fraction of the total energy released. The more significant concern lies in the high-energy radiation emitted alongside the visible light. This radiation, often in the form of X-rays and gamma rays, can have enormous impacts. One primary danger is its potential to deplete Earth's ozone layer, which protects us from harmful solar radiation. Without an effective ozone layer, life on Earth would be exposed to extreme ultraviolet radiation from the sun, potentially leading to mass extinction events. There is evidence suggesting that such events may have affected Earth in the past. Elevated levels of iron-60, a radioactive isotope produced in supernovae, have been found in ocean sediment and lunar regolith. This finding suggests that Earth may have been impacted by supernova ejecta in relatively recent geological history, possibly within the last few million years. Astronomers have recently concluded that there are currently no nearby supernova candidates posing an immediate threat to life on Earth. However, ongoing research has revealed new potential dangers linked to specific types of gamma-ray bursts. These bursts can produce long-range lethal radiation, which could be particularly dangerous for planets like ours. In summary, while Earth's biosphere is unlikely to be affected by Betelgeuse's eventual explosion, the event will be an extraordinary spectacle. Experts predict that Betelgeuse will shine brightly for over 90 days following its explosion, reaching a brilliance comparable to a fraction of the moon's light. Its striking brightness will be visible even during the day, captivating observers worldwide. This cosmic event will undoubtedly spark interest and serve as a reminder of the immense forces at play in our universe. Understanding the broader implications of such stellar events is crucial for astronomers and planetary scientists alike. Betelgeuse's eventual supernova will not only be a visual marvel, but also an opportunity to study the life cycles of massive stars and the mechanisms behind supernova explosions. By closely observing this event, scientists can gain valuable insights into stellar evolution, element formation, and the distribution of matter in the cosmos. Impact on scientific knowledge. Supernovae are fundamental to the cosmic order. They play a crucial role in dispersing heavy elements, such as iron and gold, which are essential for the formation of planets and life. When Betelgeuse explodes, the materials it releases will contribute to enriching the interstellar medium, potentially seeding new stars and planetary systems. This process, known as nucleosynthesis, underscores the interconnected nature of the universe, demonstrating how the death of one star can lay the foundation for future celestial bodies. Educational and cultural significance. The supernova will undoubtedly capture the public's imagination. Its brilliance and duration will make it one of the most widely observed celestial events in human history. Educational institutions and observatories will have a unique opportunity to engage the public in astronomy, explaining the science behind supernovae and the life cycle of stars. For many, it will be a once-in-a-lifetime chance to witness a cosmic phenomenon that has profound implications for our understanding of the universe. Technological advancements. Observing Betelgeuse's supernova will also test and refine existing astronomical instruments and technologies. Space telescopes like Hubble, James Webb, and future observatories will gather unprecedented data on the explosion. Ground-based observatories equipped with advanced spectrographs and detectors will analyze the light and radiation emitted, helping scientists to better understand the physics of supernovae. This data can improve our predictive models, enhancing our ability to foresee and interpret similar events in the future. Potential risks to Earth. While the explosion itself poses no direct threat, the high-energy radiation emitted by supernovae remains a concern. Fortunately, Betelgeuse's distance, estimated to be around 724 light-years, places Earth outside the danger zone. However, This event serves as a reminder of the potential risks posed by more nearby stellar explosions or gamma-ray bursts. Continued monitoring of nearby stars and understanding their life cycles is crucial for planetary defense and assessing long-term cosmic threats. The broader cosmic context. Betelgeuse, a supernova, will also contribute to our understanding of cosmic habitable zones, the regions within galaxies where conditions might support life. The intense radiation from frequent supernovae and gamma-ray bursts in the inner regions of galaxies suggests that life might be less likely to thrive there. Conversely, outer regions might lack the necessary elements for planet formation. This ongoing research reshapes our understanding of where life might exist in the universe and informs the search for extraterrestrial civilizations. Looking ahead, astronomers will continue to monitor Betelgeuse closely, watching for signs of its impending explosion. While it is impossible to predict the exact timing, advances in observational techniques may soon allow for more precise forecasts. In the meantime, the anticipation surrounding Betelgeuse highlights the dynamic and ever-changing nature of our universe. When the explosion finally occurs, it will be a moment of awe and discovery, offering a front-row seat to one of the most powerful and transformative processes in the cosmos. From enriching our scientific knowledge to inspiring future generations, Betelgeuse, a supernova, will leave a lasting legacy, reminding us of the profound forces that shape our universe and our place within it.